Hello students, welcome to my YouTube channel. Today I am going to continue with Introduction to Trigonometry, exercise 8.1, problem number 7. So we have the problem, if cot theta equals to 7 by 8, evaluate 1 plus sin theta into 1 minus sin theta, whole over by 1 plus cos theta into 1 minus cos theta, and also we need to evaluate cot square theta. Okay, first let us write what is given here. So given we have cot theta, this is nothing but 7 by 8, and by definition it is adjacent by opposite. Okay, so now we are going to draw a figure for this. So I have the figure. So we have the triangle ABC, in which I have taken angle C as the reference angle, which is nothing but theta, and now cot theta, so you can fill it up. So we have the side opposite to angle C, that the side is opposite to angle theta will be the opposite, that is AB, and then BC will be the adjacent side. So we can put AB as 8 and adjacent BC will be 7. Now we need to evaluate AC. Okay. So now in triangle ABC using Pythagoras theorem, so we have AC square is equal to AB square plus BC square. Then in my next step, what I can write is I'm going to write AC square is equal to AB is 8 and then BC is 7. So 8 square plus 7 square. So 8 square is 64 plus 7 square is 49, which will give you 113. So that means in my next step, I write AC will be equal to square root of 113. Okay, so let me put AC value as 113. Then I'm going to write sin theta, find the value of sin theta. So definition of sin theta is opposite by hypotenuse, which is nothing but 8 by root 113. So we have opposite by hypotenuse, that is 8 by root 113. And at the same time, we have cos theta also. So cos theta definition is adjacent by hypotenuse, which is nothing but 7 by root 113. Okay. Now I have the problem. For this, we need to evaluate 1 plus sin theta into 1 minus sin theta, whole over by 1 plus cos theta into 1 minus cos theta. So actually, here we are going to use the identity a plus b into a minus b. This is nothing but a square minus b square. So using a plus b into a minus b, we get a square minus b square. So instead of a, for the numerator, we have a as 1 and b as sin theta. And so that will be 1 minus sin square theta we get in the numerator. And for the denominator, for instead of a, you have 1, and instead of b, you have cos theta. So in the denominator, we get it as 1 minus cos square theta. So let us write that. So now the given expression becomes 1 minus sin square theta into by 1 minus cos square theta. Now I'm going to substitute the value of sin theta, which is 8 by root 113, and cos square theta, and replace it by 7 by root 113. So now we can write a fraction here. Excuse me. I'm going to write it as 1 minus 8 by root 113, so whole square. And then similarly, in the denominator part, I'm going to write 1 minus 7 by root 113, the whole square. Okay. Then I'm going to, what will happen now? Next step, I'm going to write the fraction again. So now this time 8 by root 113 whole square. So this becomes 64 by 113. And here also 7 by root 113 whole square becomes 49 by 113. So that means the numerator will be 1 minus 64 by 113 and denominator will be 1 minus 49 by 113, which is nothing but it's equal to, then we apply the cross multiplication method, wherein we get the numerator as 113 minus 64 by 113 and denominator we get it as 113 minus 49 by 113. So just cross multiply. So 1 into 113, 113 minus 64 by 113. And here also the same way. Let me show you. So here we are going to take it as geometry as 1, here also 1. So first 1 into 113 is 113 and 1 into 113 is 113 here. And then 1 into 64 is 64. Okay, similarly 1 into 113 is 113, 1 into 49 is 49, and then 1 into 113 is 113. Okay, so now next thing what we are going to do is we are going to cancel 113 both numerator and denominator. Okay, we can cancel in this way also. Okay, now what will be left in the numerator is the question. Now here, so we get as 49 by 64. So 49 by 64. This will be our answer. Now, my next question is we need to evaluate cot square theta. That's the second problem we have. So cot square theta, basically, it is nothing but, so if you look at the figure, we have, it is adjacent by opposite, right? So that is, we have 7 by 8, the whole square. So 7 by 8 whole square, which is nothing but 7 square is 49, 49 by 64. That's our final answer. Okay. Then I'll go for the next problem. Eighth one. If 3 cot A equals 4, check whether 1 minus tan square A by 1 plus tan square A equals cos square A minus sin square A or not. So for this, here we are given cot A. So cot A is 4 by 3 because 3 cot A equals 4 means so cot A will be equal to 4 by 3. By definition, it is adjacent by opposite. So for that, I'm going to draw a figure for this. So we have the triangle ABC in which I've taken angle A as a reference angle. So only I put a marking like this. Okay, so angle A is a reference angle here. And then by definition, we have adjacent by opposite. So fill the adjacent with 4 and opposite with 3. Okay. Now by using Pythagoras theorem, so we have by using Pythagoras theorem, we have AC square is equal to BC square plus AB square. Okay. Now the next step, what I want to do is, so here again we have AC square is equal to, so BC value is 3 and then AB value is 4. So 3 square plus 4 square, which is nothing but 9 plus 16, which is nothing but 25. Or AC is equal to, AC is equal to square root of 25 is equal to 25. Okay. Next, I need to evaluate 1 minus tan square A by 1 plus tan square A. So for that, I'm going to take LHS. So LHS is equal to 1 minus tan square A by 1 plus tan square A. Now, what is tan A definition? So we have tan A as 3 by 4. Okay. So we can write that. So that is, we are going to write a fraction here. So numerator becomes 1 minus 3 by 4 whole square, and denominator becomes 1 plus 3 by 4 the whole square. And then, which is equal to, so now in my next step, the numerator. So let us write the numerator here. So now we have numerator as 1 minus 9 by 16, and at the same time, denominator we have 1 plus 9 by 16, which is nothing but, now we do the cross multiplication, wherein I get numerator as 16 minus 9 by 16, and then denominator will be 16 plus 9 by 16 equals to, now as usual, so 16 and 16 gets cancelled here. So we can cancel that 16 here and here. Now next step, what I can do is, I can write it as 7 by, so 16 minus 9 is 7, and 16 plus 9 is 25. So we get 7 by 25. So that's our final answer. Now, next we are to take the RHS part. RHS is cos square A minus sin square A. We take it. And then, what is cos definition? That is, it is nothing but adjacent by hypotenuse, that is 4 by 5. Okay. So that is, I write 4 by 5 whole square minus, and then sin A. Sin A is nothing but, we have opposite by hypotenuse, that is 3 by 5. So that's why I'm going to write it as 3 by 5 whole square, which is nothing but, so now it is, we get it as 16 by 25 minus, so 3 by 5 whole square, which is nothing but 9 by 25. Now we have the same new denominator, so we can subtract the numerators. So 16 minus 9 will give you 7. So the answer will be 7 by 25. Now if you look at it, if you look at this particular thing, now here you have LHS both 7, LHS and RHS both equal to 7 by 25. So that means the given, the problem, so it is verified. So here we can say that here LHS equal to RHS. So here LHS equal to RHS, hence proved, we can write hence proved. Okay. So we can, so this is statement is true. Now I go for the next problem. We have in triangle ABC, right angled at B. If tan equals 1 by root 3, find the value of sin A cos C plus cos A sin C, and cos A cos C minus sin A sin C. Now for this, we are going to draw two figures for this. Okay. So first we are going to draw the two figures. So I have the figure. Okay. Now, I have for the first one for sine A, that is for A, we are going to take two things. So now if you look at it the problem, you have sine A and cos A. So we can take in one triangle, you're going to take A as a consideration, angle of consideration or the reference angle. And in the another figure, you're going to take C as the reference angle. Okay. So accordingly, you're going to fill the value. Okay. So now, if I take this triangle ABC, okay, so now you have 1 and root 3, okay, so that is tan A is opposite by adjacent. So I write 1 by root 3, and then what will be the AC? AC value will be 2 by using, excuse me, by using the Pythagoras theorem. So we get AC as 2. Now, with the same dimension, you can take this another triangle, okay? But in this time, the opposite and adjacent positions are going to change. So now this time, it will be AB will become the opposite and BC will become the adjacent, okay? Then, now, I am going to take the problem sin A. So we're going to take this sin A into cos C plus cos A into sin C. So this will be equal to, now here, what is sin A? So sin A, it is opposite by hypotenuse, that is 1 by 2. So I'm going to take 1 by 2 here. Then cos C, so into cos C value is, so take the second figure, and cos C definition is adjacent by hypotenuse, that is how much value? It is 1 by 2 plus cos A. So cos A value is root 3 by 2. Yeah, that is cos A, so adjacent by hypotenuse, root 3 by 2, and into, and again, sin C. Sin C means, so to look at the second figure, sine definition, that is opposite by hypotenuse, it is root 3 by 2. So again, we get root 3 by 2. So now we have, so equal to, so 1 by 2 into 1 by 2, we get it as 1 by 4, and then plus root 3 into root 3 is 3, and 2 into 2 is 4. So get plus 3 by 4, or it's equal to, then you have, so same denominator, you can add it up, and numerator will be also 4 only, 1 plus 3, 4. 4 divided by 4 will give you answer as 1. So this will be equal to 1. So it's the answer. Then I have the next one problem as cos A into cos C minus sin A into sin C, which is nothing but, so here we have, so we can refer here easily. So that's why I taken down. So now here we have cos A value is root 3 by 2 into 1 by 2 minus, what is sin A? Sin A is 1 by 2 into root 3 by 2. So this will be equal to, so you get it as, so 3 into 1 is 3 and 2 into 2 is 4. So you get it as 3 by 4. So 3 by 4 minus root 3 by 4 is equal to, so 3 by 4, 3 by 4 subtraction, you get it as 0. So this is the answer. Okay. Now I move on to the next question. So I have the question as in triangle PQR, right triangle at Q, PR plus QR equals 25 centimeter and PQ equals 5 centimeter. Determine the value of sine P, cos P and tan P. Okay. So now for this, I'm going to take a figure for this. So given, so let us write given, what is given? PQ equals 5 centimeter. So given PQ equals 5 centimeter and PR plus QR equals 25 centimeter. So take, we take PR as X. Okay. So that means, this means that, so now I get X plus QR equals 25. Okay, because PR you are going to substitute with X, so you get X plus QR equals 25. And that means to say you have QR equals 25 minus X. So QR equals, so you get QR as 25 minus X. Then you are going to use, so let us draw the figure for this. So already taken the figure now. Okay. I taken the right angle triangle PQR in which PQ equals 5 centimeter and then QR you can write it as 25 minus X. So PR is already taken as X. So we are going to use the Pythagoras theorem. So now using Pythagoras theorem in PQR, we have, so we have PR square. So PR square is equal to PQ square plus QR square. So PR square is equal to PQ square plus QR square. Then I am going to substitute the values here. Okay. So we have PR square is X square equals to PQ square. PQ square is 5 square. So we can write it as 5 square plus QR square. So that is 25 minus X the whole square. There's nothing but I get it as X square equals to 25. So it is now we have 5 square is 25 plus then we have apply the identity a minus b whole square. So a minus b whole square is a square minus 2ab plus b square. So we are going to apply that identity. So a square means 25 square minus 2 into, so 2 into AB, that is 25 into B means X we are going to take minus, that is plus B square plus X square. Then I'm going to, so we can cancel this X square and X square as such. So we can cancel that X square. So X square and X square gets cancelled. Then, so obviously this LHS part has become 0 now. And then we have, so 25 here and 25 square 625 and 2 into 25 into X. So it will becomes minus 50X. Okay. Next step, what I can write is, so it's equal to 0. So 625 plus 25 will be 650. 650, if I move it to the left hand side, it becomes minus 650. Okay, equals to minus 50x. 50x. Or we can write it as, or x is equal to 650 by, so here minus and minus gets cancelled. We can cancel this minus sign. So you get it as 650 by 50. And then x will be equal to, or x will be equal to 13 because 0, 0 gets cancelled. 5 ones are 5 13s are. So 0 and 0 gets cancelled. And 5 ones are 5 13s are. Then, now what is QR? So QR is nothing but, so already we have taken the QR as 25 minus x, correct? So 25 minus x, so x we can write it as 13. Okay, so that means 25 minus 13 will give you 12. And then, and PR equals x, which is nothing but 13. So now let us go back to the problem. Determine the value of sine p, cos p, and tan p. Now we need to find out the value of sine p, cos p, and tan p. So if you take here, we need to take p as the reference angle. So that's why QR will become opposite side, and this PQ becomes the adjacent, and PR is the hypotenuse. Okay. So that means now, let me write it. Now we have sine P as 12 by 13, and then cos P value is 5 by 13 because cos P definition, as I told you, cos definition is adjacent by hypotenuse. It is 5 by x. So x value already you know, right? X value is 13. And then tan P. So tan P is 12 by 5. So that's the answer. Then I have the next question. Problem number 11. Excuse me. State whether following are true or false. Justify your answer. So I have the first question. The value of tan E is always less than 1. So for this, I'm going to consider a triangle with the following dimension. Okay. Now I'm taking a triangle here. Okay. So here, if you look at this figure, I have taken a triangle ABC with E as a reference angle. See, tan A means take E as reference angle. That's a method you need to follow. Then what will be BC? BC will be the opposite and AB will be the adjacent. And now you know Python triplet 3, 4, 5. So remember that always. So I taken AB as 3 and BC I taken as 4 and then AC will be 5. Okay. Then let us consider, so let us write a statement now for this. Let us write a statement. Let us consider the triangle, a right angle triangle with dimensions as mentioned below. Okay. And now I'm going to write the tan A value. So tan A, if you look at tan A, definition is opposite by adjacent, which is nothing but 4 by 3. Now 4 by 3 value, it is 1.33. Actually, it is 1.3 bar. You get a recurring decimal as such. So it will be 1.3 bar, in fact. Okay. So now this 1.3 bar, I told you, no, this will be greater than, it is greater than 1 as such. So, correct. So what we can write is here. So here 1.3 is greater than 1. So our statement says that the tan A value is always less than 1, but it is contradictory. We are getting a contradictory statement. So what I can write? So I can say that given statement is false. Okay. So we can write like this. So the given statement is false. Okay. Next question I have is, we have like this. Secant equals 12 by 5 for some values of angle A. Now here, let me write it. Given secant A is 12 by 5. By definition, it is hypotenuse by adjacent. Okay. Now here, actually, what has happened is that the hypotenuse is greater than adjacent. Correct? So you should note that, always remember that hypotenuse will be always greater than adjacent and opposite sides. So that's why this given statement is possible. So what I write is, so the given statement is true, I write. So hence the given statement is true. Then the next question I have is, cos A is the abbreviation used for the cosecant of angle A. See, actually, what is cos A? Cosine of angle A. So we can write like this, cos A, write like this, cos A is the abbreviation used for the cosine of angle A. Hence, the given statement is false. Then I have the next question. The fourth one, cot A is a product of cot and A. See, cot A is a function, in fact, okay, trigonometric function. So now we can write like this, cot A is not a product. So it is cotangent of angle A. So hence the given statement is false. I have one more question. I have fifth one. Sin theta is 4 by 3 for some angle theta. So given we have sin theta, which is 4 by 3. By definition, sin theta is opposite by hypotenuse. If we notice properly, here opposite is in fact greater than hypotenuse, which is not possible. So I can write the statement as here. Here, hypotenuse is less than opposite side. Correct? So we should note that we know that. So we know that in a right angle triangle, hypotenuse is always greater than opposite and adjacent side. Hence, the given statement is false. Okay. So that's it, students. Now we will be taking some more problems in my next session. Until then, goodbye. Take care.